What is a hydrodynamic boundary layer in convection? Imagine standing next to a flowing river. The water near the bank moves slowly, almost stuck to the surface, while further out, it flows faster. That's similar to what happens with fluids near a solid surface. When fluid moves past a surface, a very thin layer forms where the flow changes from zero speed at the surface to the faster flow away from it. This is called the hydrodynamic boundary layer. It forms because of the no-slip condition, meaning the fluid particles right at the surface don't slip past but stick to it. As you move away from the surface, the fluid particles start moving faster, creating a velocity gradient. This gradient is caused by viscous shear forces within the fluid, which resist the flow and cause the velocity to change gradually. In convection, which is the transfer of heat through fluid motion, this boundary layer plays a big role. Inside this layer, the fluid velocity shifts sharply from zero at the surface to nearly the free stream velocity. The thickness of this layer is measured from the surface to the point where the fluid reaches about 99% of the free stream velocity. The size of this layer depends on factors like the fluid's viscosity, the speed of flow, and the shape of the surface. The flow within this boundary layer can be smooth and orderly, called laminar flow, or chaotic and mixed, called turbulent flow. Near the start of flow, it tends to be laminar, but further downstream, it often becomes turbulent. The behavior of this layer influences how well heat is transferred from the surface to the fluid or vice versa. The shear stress within the boundary layer affects the heat transfer rate, which is important in designing systems like heat exchangers, cooling devices, or aerodynamic surfaces. For example, in forced convection over a flat plate, the boundary layer develops along the surface, affecting both the velocity profile and the temperature distribution nearby. Understanding this layer helps engineers optimize how heat moves in different systems. In essence, the hydrodynamic boundary layer is a tiny but vital region where fluid speed changes from zero to the free stream speed, and it has a big impact on how heat is transferred near surfaces.